In this tutorial, we will explore compressors and other dynamics processes. For this, we will use the extremely versatile M-Dynamics, as it has every feature we need. We start by playing a challenging short white noise sample that has an increasing audio level. Let's set a very low threshold and maximum ratio and see what happens. At some point, the output level stops rising. Instead, the gain reduction meter shows that the compressor is doing something. We will explain what the compressor does later, but first, let's cover the basic parameters of threshold, ratio, attack, and release. These parameters are all available from the simple default screen, but by selecting Edit mode, we can show them in more detail. First, we will look at the compression graph on the right and the two main parameters controlling it, the ratio and the threshold. Ratio controls how steep the top part is. Threshold controls where the top part starts. Let's look at what the graph is telling us. We will set the threshold at -12 dB and the ratio at 2:1. The x-axis shows the input level and the y-axis the output level. Note that the audio level isn't loudness nor peak level that you would see on a waveform display. If the input level is -24 dB, hence below the threshold, the output is -24 dB as well, so the compressor does nothing. If the input level is -12 dB, which is at the threshold, the output level is still -12 dB, and so the compressor still does nothing. Now, if the input level is -6 dB, it is above the threshold, so the compressor starts working. A ratio of 2:1 means that a 2 dB increase in input level causes just a 1 dB increase in output level. As threshold is -12 dB, at -6 dB the input level is 6 dB above the threshold, so with a 2:1 ratio, the output level is now -9 dB. The compressor turns a -6 dB input level into a -9 dB output level. This is called -3 dB gain reduction. Let's see what happens with our white noise sample plugged in with these settings. The vertical line displays the input level. The input level never even reached the -12 dB threshold. Let's decrease the threshold and try again. We can also increase the ratio to demonstrate the effect more. As soon as the input level exceeds the threshold, the increase in the output level almost stops and the gain reduction meter starts working. The higher the input level, the more the compressor worked, which was shown by the increasing gain reduction. Now let's check the same thing with a drum loop. Let's use some extremely aggressive settings just to show what the compressor can do. The harder we pushed the compressor by lowering the threshold and increasing the ratio, the more gain reduction it indicated. When used carefully, the compressor can make a sound better, but when pushed too far, it can completely squeeze the sound. This brings us to the main question. Why do we need to use compressors? First, macrodynamics. Mixes or even separate tracks are often too dynamic to be heard properly against our noisy environments. Loud parts would be too loud and quiet parts would be too quiet, so the listener would have to constantly change the volume. Second, microdynamics. Many instruments themselves have a large fluctuating dynamic range. For example, every drum hit has a very powerful attack and a comparatively very quiet sustain. Both of these problems can be solved by a compressor. There are two basic approaches. The first is to use a very low threshold and ratio. This forces the compressor to work constantly, but at a low level. As you can hear, even with a small ratio applied, the compressor may still squeeze the audio a little too much. But when used carefully, this approach can provide very transparent results. It is also quite easy to set up, as the threshold can usually be set at any number low enough. The ratio is the parameter that makes the difference. The second method is to use a high threshold, so that the compressor is working only occasionally, and a higher ratio. The idea is that louder sounds are reduced, while the level of the quieter sounds stays the same. In our case, the drum hit attacks are compressed, but the sustains are left. Or, to look at it another way, the sustains are louder compared to the attacks, which are now quieter. This method is not as easy to set up, because the threshold parameter setting is now as important as the ratio. The threshold is usually set just above the sustain parts, which you can find easily by looping the sustain in your host. Let's move on to the level detector. This has two basic parameters, the attack and release time. The input signal is processed by several advanced algorithms to produce a so-called level. We can think of this level as being similar to loudness, although in reality it is not actually the same thing at all. The envelope follower is one of the most important factors in the level detection and is driven by attack and release times. Simply put, the attack time defines how quickly the level can rise, and the release time sets how quickly the level can fall. Let's start with the attack time. If we set the attack time to 10 milliseconds and play a drum hit into the compressor, it will take about 10 milliseconds for the level to get to its maximum. A simple way to understand what attack time means is to look at it this way. We can imagine that the attack time is the delay it takes for the compressor to recognize the increasing input level. This may sound surprising, because why would we delay the input? Firstly, there are technical reasons. And secondly, we may want to do this intentionally, to pass part of a drum attack through uncompressed, for example. It turns out that the higher attack times give a more natural output, while lower values provide more compression and therefore a more squeezed sound. Let's see what attack time does with our drum loop. Again, we will use very aggressive settings. At an attack time of 0 milliseconds, the audio is very squeezed. At 10 milliseconds, the hits sound quite natural, but the compression is still highly noticeable. With higher attack times, the level may not even reach the threshold. Now let's move on to the release time. The release time is usually set at least as high as the attack time, otherwise the level may not even reach the threshold. With low release times, it is usual to notice some sort of distortion caused by the level fluctuating too quickly. With high release times, the level cannot go down quickly, so we may experience lots of stable compression. This sounds clean, but makes no sense as it behaves like a simple gain control. So low attack and high release settings are generally useless. It's probable in most cases you'll have a release time that's slightly higher than the attack time, say up to 10 times its value. Let's see what effect the release time has on our drum loop. With the release lower than the attack, there's a lot of distortion. With the release set at 10 times the attack time, we hear noticeable pumping. At 500 times higher, the level stays constantly high. The best results are achieved with a release time that's similar to the attack. It's all about finding the right combination of attack and release times for your particular audio material. Using very aggressive settings like we have done to find these values is often a good approach. We can then adjust the threshold and ratio to control the amount of compression. The only difference between expanders and compressors is their processing shape. The purpose of an expander is to increase the dynamic range below the threshold. Hence, an expander makes a quiet part even quieter. Use this switch to turn M dynamics into a downwards expander. Everything works the same except the ratio works in the opposite direction. Let's see what an expander does. With low ratios, the effect may be almost unnoticeable. With medium ratios, the expander may diminish ambience and sustain. With high ratios, the expander basically works like a gate. In fact, gates usually have a very similar shape but have different controls. M Dynamics gate doesn't have a ratio, but has a size parameter instead. The size controls how quickly the shape reaches the bottom, usually silence. Gates are used to remove noise and other unwanted artifacts from in between the relevant audio. In most cases, you would use a very low threshold. An important thing to notice is that compressors, expanders, and gates only differ in their processing shapes. With M Dynamics, we can combine all of them at once. Enable the gate, use Processor 1 as an expander and Processor 2 as a compressor. This lowest part belongs to the gate. This one belongs to the expander. And this one is the compressor. By turning on the custom shape mode, we can even draw our own shapes. So we can make more complicated combinations of the usual tools or use the dynamics processor more creatively. Now we have an understanding of the most basic parameters and principles, we can go into a little more detail. The range parameter of a compressor changes the processing shape in quite an unexpected way. This is, however, very useful as it basically limits the amount of compression. Watch the gain reduction meter to see what it does. With the range control, it's easy to ensure the audio never gets overcompressed, while still removing any unwanted dynamics. The knee changes the character of the compressor. A hard knee usually sounds more aggressive, and a soft knee causes more compression. There is no rule of thumb for using the knee. However, be aware that just because the soft knee looks better in the graph, it doesn't mean it sounds better. Most compressors provide one or more auto-release modes. M-Dynamics has 5 of them, and each works in a different way. Some of them have been inspired by existing analog devices. Others are based on purely logical ideas. Auto-release mode basically means that the release time can vary according to the current situation. M-Dynamics still provides a release time parameter in auto-release modes, though. There is no need to fully understand the way auto-release modes work. The only rule is that it should sound good with your audio. Peak hold pre-processes the level going into the envelope follower. The follower has a tendency to ignore short transients. Peak hold can help this and is commonly used when gating drums. RMS length is another level preprocessor. With a minimum value, M-Dynamics becomes a peak compressor. Peak compressors are very quick and aggressive. The downside is that they can often distort the audio if pushed too far. With higher RMS lengths, the results are usually much softer, but as the processor reacts more slowly, it is often not suitable for drums, etc. Look-ahead can avoid distortion and pumping in some cases, and can make the compressor extremely fast. Normally, the compressor needs time to adjust to the incoming transients, drum hits, according to a configured attack time. Look-ahead delays the input by a specified amount, so that you can make the compressor react to audio that hasn't come in yet. As a result, when a transient occurs, the compressor already knows about it. This feature is mostly used in limiters, which are really just specially configured compressors. Most compressors are equipped with input and output gains. Input gains are used to adjust input signals that are too quiet or too loud. The output gain is used to compensate for any gain reduction the compressor creates. So if the compressor creates an average -5 dB gain reduction, the output gain can be set to +5 dB to maintain the output loudness. The temp gain is a less common feature, which is applied to the input and is then removed on the output. It also takes into account the current ratio. It can be used to control the amount of compression. The same can be achieved by manually adjusting gains and thresholds. However, the temp gain is both quicker and safer, as it also compensates for any change in loudness. Parallel compression is based on mixing the dry signal with the compressed one. Compressed signals can often sound too overprocessed. Parallel compression can pass some of the transients through and so make it cleaner. M-Dynamics lets us use the dry-wet controller to adjust the parallel compression. channels controls if and by how much all stereo or surround channels are compressed in the same way. With link channels enabled, the connection between channels is kept intact. But disabling the channel link will force the compressor to fix level differences between channels. Notice the two level lines instead of one now, as there are two input channels available.